Okay, for people who are joining this live stream, this is another episode in our long-running effort to design chemical computation functionality for the upcoming version of Wolfram Language. By the way, I had reported, I don't know is somebody from PM Project Management here?
Yes, I'm Andrea. I'm here today.
Okay, so I reported like 5 times this fact that there's a period at the end of that 150% thing. Right? Can you make sure that gets reported to the front-end group?
Sure.
Okay, let's get going here. So we haven't talked about pattern molecule, have we?
No, we haven't.
I think it's a weird name. I think it should be molecule pattern.
I have no objection to that. I was using query molecule, but I was told that that was not so good. So, but I can use
that's awful. Pattern. Well, let me understand what it is. In what sense is it a pattern?
So essentially, it has the same structure as a molecule, but it doesn't do any of the checks necessary for chemical to make sure it's a valid chemical. So essentially, it wants to get used in functions like molecule position or molecule plot. It doesn't have any formatting values at the moment. That is something we should talk about.
So I don't understand. So this is a molecule that is, I mean, if I make that into a pure molecule here, right? Somebody wants, you want to switch off your video, thank you. If we make that into a pure molecule, in that particular case, it will work, correct?
Yes.
Okay, so let's say I add to this a tungsten, okay? Now, that didn't work, but it produced something. What does that produce? It produces a thing that isn't actually a hung together molecule, correct?
Right, it's a disconnected structure.
Okay, so what's wrong with, why is pattern molecule not just molecule?
So one thing that you can do in a pattern molecule that you can't do in a regular molecule, you could mark an atom as being aromatic. You could mark an atom as having a calculated partial charge within a particular range. You could say that an atom has a...
I don't understand. These are things that you can't do in a molecule because you're being vague about. I mean, in your pattern case, you want to be vague here. Rather than being specific that it's oxygen, you want to say something less specific. Is that correct?
Right. You could use alternatives, O or C.
Okay, fine. But I don't understand why that isn't just molecule, why it isn't just something like this, okay? And it's just a molecule, right?
Right. So at that point, let's see.
I assume we have Michael here. Yes.
No, Michael's on PTO.
Do we have Bob here?
Yes, Bob should be here.
Bob's here.
Okay. Why is Michael listed as being in this meeting when he isn't here?
As it was originally scheduled, he was still here. It was moved to today so that Bob can join us. It was either Bob or Michael.
Okay, whatever.
But as you can see here, here's the carbonyl he is using is for a substructure here, for a functional group. So it's not really a molecule, it's just only part of a molecule.
Right, and so it could be possible to use the molecule head to represent a molecule pattern. There would just have to be checks to see whether it's a pattern or not before I try and do any of the stuff that I've... so there would have to be a quick check to say, are you a pattern or are you a regular molecule, and to see which code path to go down. So using a separate head made it easier for me in writing the functions, but it's not absolutely necessary.
Right, so it's wrong for users.
Yeah, and besides, the pattern itself as a symbol is only, it basically provides a handle to the pattern by which you can use it in a back reference. Underscore by it, blank by itself is a pattern, but it doesn't require the wrapper pattern around it.
No, it certainly doesn't. I mean, in other words, I think what we need is something where there is a display form for this.
Right. So for certain really simple cases, a display, making a display will be very easy. For others,
then don't worry about it. Then it just comes out like this, and everybody's happy. Right.
Right. And so then,
yeah.
So we have the function molecule Q, which up until now only will only give true if something is a valid.
Well, I think it's the wrong name. I think it's the wrong name for that. I think it should be something like, what is the real criterion for a molecule being a validated molecule, so to speak?
That actually exists, that it can be made.
No, I don't believe you. We don't necessarily know that, do we? Do we know that?
It has to have, the valence has to be satisfied within the standard valence rules. Shouldn't have any missing hydrogens. Well, actually, hydrogens are a different issue, but it definitely does not have to be something that's makeable.
Right. So, I mean, is it something like structural molecule Q or something? Molecule Q doesn't cut it. I'm sorry. It just doesn't make any sense, because in addition to that, we mean, we may represent these cluster type things as a molecule, the things where there are multiple disconnected pieces and so on in a molecule. Am I making sense?
Yes.
Right. So it doesn't make sense to call it molecule Q. It's slightly an abuse of things to call this molecule, right? But it's okay. But so what we need to do is to say, what is the aspect of this thing that makes it valid in this sense? Get what I'm saying?
Yeah. Structural Q would be good as long as it's understood that it's strictly the topology, the two-dimensional structure, and not a 3D structure.
Well, okay. So give me a better chemical name for this. What is the attribute that the thing has that makes it valid in this sense?
Valid valence Q, something like that.
Okay. So what would be a valence balanced? I don't know whether that makes sense. I mean,
right. I mean, so aside from the name, the way that the reason that this function is so necessary, I mean, what it really tells the user is that this has passed all of the checks, and you can use this molecule in any function, and it will behave like a Wolfram Language molecule.
But that's the slippery slope, because there's going to be functions where you can't do that for whatever reason, because the molecule is too big, because it has the wrong atoms in it, blah, 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 blah. So it isn't the case that this is a check that everything is going to work. This is a check that the molecule is not obviously sort of non-functional, so to speak.
But we have also positively charged ions, right? We support also as a molecule, and then it's not balanced anymore.
Right. So so in that case, it's not that it's so that I'm not the biggest fan of balance.
You cannot call it balance. It's not the right thing.
No. Okay. Fine. So tell me what is right.
So to go super simple would be to give it a sub value that is just valid Q.
No, that won't work. Can't do that. What do you mean? You mean molecule blah 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 or valid? That's a bad idea. But we need some function that checks the molecule and decides whether it is a blah molecule. I mean, we could say structurally. I don't know whether structurally valid Q, but that sounds wrong, and it's too general. It's too general. It's not referring just to a molecule. All right, we're going to have to come back to this.
Right. So
I wish Michael would have had something useful to say about this, I think. Because I think there are other places in the system where we have similar kinds of things. Okay, again, can you tell me, if you're explaining to somebody in chemistry speak, what is this thing checking for? What would you say?
So I would say it's checking for chemical validity, that the molecule you've entered meets the generally agreed upon rules of chemical validity, and that you don't have 10 bonds to carbon, that you don't have 4 bonds to nitrogen with no charge. Those are the areas where it's really going to come up to users is why isn't this molecule I entered valid?
Right,
Or why is it being marked as invalid?
Just checks for contradictions. So at the moment.
Well, so you're saying chemically valid Q.
Essentially, yes, chemically valid Q. And in the reference page, we could give the details of what that means.
Yeah, and it may be that it has a second argument that will define could have various possibilities for what's being done there. Jason, put yourself on mute, please.
So you could say strict or fuzzy, so you can, or you can say iron, so you can, which is actually not bad.
Fine.
And so then it would by default, or in the single argument form, it would return false on a pattern, and then with a second argument,
Like you can make it more strict. Yeah, you can make it more strict. Say, I only want the valence. All valence should be balanced.
Yes, this seems reasonable to me. And in some cases where you can have, a single molecule versus clusters versus whatever else. All right, let's keep going. I like that name for now. Okay, what is this about? So molecule position. So we got a molecule here. For goodness sake, Jason, please find a way to get a headset that doesn't have too much gain. Okay, in any case. All right. Okay, so normally this would just be, I see, so this is nice. Now, why can this here, it has to be 6 items.
I was thinking about this when I was writing this up, that one could omit the atoms list and just, as long as the indices referenced in the list of bonds forms a, we could just take the list of indices.
Alternative version of this would be repeated blank, comma 6. Is that right? I forget the syntax of repeated.
6 has to be inside of a list to be exactly 6.
Okay.
But otherwise, that would do it.
Okay. All right. Okay, fine. So now if I go like this, splarf. Why is that? Why didn't that work?
So let's see. So I didn't set up a pattern to match on repeated.
Yeah, so we need that.
Okay.
I mean, it should just be a pattern. It should just be a generic pattern.
Right. So with a lot of these, I have to I hard code the patterns because I need to build up a library object out of it.
That sounds like a bad idea.
So it's not using the Wolfram Language pattern matcher except in certain cases.
Okay, so that seems like a nightmare for testing. Who has started testing this?
So Sean is. I've been talking with Sean Clark, and I've been making an extensive test suite as I do this. But
yeah, fine. But I think that particular issue of Wolfram Language patterns that are or not supported, first of all, you have to have reasonable messages about it. And second of all, it seems like you need a fallback mechanism where you go through the general pattern system. But let's keep going. Molecule position seems, now, what is it exactly returning? It's returning, so there are 2 benzene rings, and it is at those positions, and those are the referenced. So if these things were named, if that was an association, no. How do we deal with named elements in a molecule?
So you're allowed to reference the elements by their name, but we don't return the name. The canonical form is always the indices, the index.
So position always returns indices.
Yes.
Okay. So what's interesting here is, so I mean, that position is rather different from our usual position because it's not succession of levels, that's a list of positions.
Right, which is what initially I was calling this fine molecule substructure, specifically because it doesn't. There's the concept of levels here doesn't apply in general. Like, so yeah, it has a different syntax or different return type than position.
And why did we change it to molecule position?
Well, let's see. We didn't like fine molecule substructure. It was too wordy.
So this is actually molecule extract, if I'm not mistaken. Is that right, or does extract have different? Or maybe this is molecule. Wait a minute. Molecule part would usually give this as a list of elements, right? If it was just part, if I had here ABC part, 211, for example, that would give me a list there, right? So molecule part is giving me a molecule of those sub-elements.
Yes.
What do we do for subgraphs? What do we do? What is the analog of this for graphs? Can Charles say something about that? Charles? Hello, Charles. Is Charles here?
Hello, really, sorry. I was trying to help Roger for his connection.
Okay, shall I repeat the question?
Yes, please.
Okay. Molecule part is extracting essentially the subgraph with elements 2, 4, 5 from the molecule. I'm asking, what is the analogous function for graphs?
The subpart. So we have some subgraph, which essentially allow you to build a subgraph from the original graph. So you can list the list of vertices and edges.
Well, what about if I just give a bunch of vertices?
Yeah, that will work. You'll just pick.
Okay, so the analog of this is, this would be, if M was a graph, I could say subgraph of M, 2, 4, 5 here. Is that correct?
Correct. Yep.
Okay.
And so the extension here is that if you give molecule part and then a list, and then give a list of lists, you can get back a list of molecules. Which I don't know if that's a common enough thing to want to do with graphs in order for that to have been implemented. It's not on the documentation for subgraph.
Charles, so is subgraph listable in its part specifications is the question here.
Listable in specification. Well, it depends because a vertex can itself be a list. So we are kind of extremely careful on that. But it's listable. If you give a list of vertices, you run the list of vertices. But it's...
No. But in this case, this molecule thing is, what Jason is saying is that if there's a list of lists here, it will return a list of molecules. Your point is the actual label of a vertex could be a list.
Yes, so that's why. Right. That's why
so
we haven't made
it can't be listable. Okay, fair enough. That's a perfectly reasonable argument.
So this is something I was originally calling. I was calling it molecule extract, but it was decided that the differences between the return and for position and extract was different enough that we should go with part.
Okay, my question here is, what is the analog of molecule position for graphs? Is there a graph position?
No.
If there was a graph position, is this what it should return? So the graph, when you find a subgraph in a graph, how do you return where the subgraph is?
Well, for graph, we build the subgraph, so we generate the actual resulting graph. We don't per se describe the position.
No. I'm saying if I want to find a subgraph in a graph, how do you specify where that subgraph is?
Examples I've seen have been with highlight graph.
Yes, but we don't have a canonical way to describe the position of subgraph.
But
the subgraph has a description in it. So subgraph has an argument structure to describe what subgraph you're asking for.
Well, but you wanted
I understand, but I'm saying what's happening here is we're saying given a graph pattern, okay, I want to know, I mean, one question would be return the subgraphs to me that match that pattern, right? Which is another thing you might want here, which is molecule cases. Am I making sense?
Yeah, that does.
Okay, so now, in the case of subgraphs, graph cases would be a bunch of subgraphs, but graph position should be a specification in the original graph of where those subgraphs occur. See what I'm saying?
But how will you refer to those subgraphs? I mean, what's the...
But a list of nodes, a list of vertices. Why not? In other words, when you extract something from a graph, when you extract a subgraph, well, let's look at the subgraph function.
So you also want a submolecule then?
Okay, this prototype build has broken documentation. I don't know yet. Okay, so there it's given a bunch of vertices, right? So that then returns the actual subgraph, right? With all of its connections. It says, pull out these vertices, and there are no dangling hairs, is that correct? In what you mean by subgraph, there's never anything dangling. Is that correct? Do you understand what I'm saying?
Yes, there's no dangling edge. Right?
Do you say that in this documentation? You really
the graph is defined. The graph itself is defined that way. You can't have an edge without having a vertex that it's vertices that it's connected to.
Fair enough.
Yeah, we kind of.
So that's the definition of graph.
Okay.
On the other hand, graphs can have isolated vertices.
Sure. Okay, so one issue for subgraph, I mean, as we think about graph rewriting and things like that, the idea of a subgraph with dangling, tentacles is going to be needed. And that's similar to the pattern molecule construct that you have, I think. In other words, it says, well, I don't know how similar it is. There is an edge, but we're not saying what it goes to.
Right, and there's going to be lots of implicit edges in a pattern molecule that we're not specifically not saying. So that carbon there that has two bonds.
Is it roughly equivalent to the third argument of subgraph there, where we take a pattern? You can roughly say directed edge 1, blank.
I'm sorry, say that again? You mean the third usage case here?
Right. You can have sort of one edge blank. See what I'm saying?
So in that way, subgraph. Let's see. So I mean, it will. The pattern can be either a vertex pattern or an edge pattern.
So there it's a blank arrow 3. Right. I see the case here.
Right, and that's an undirected graph, right? So that goes both ways.
Right, but I mean, so that is similar to a dangling end, isn't it?
No, I mean it is. It says anything. The blank is obviously anything.
Right,
but it's not dangling because it matches whatever it matches that actually exists. So what comes out is not dangling.
Yeah, it's just
I understand. It grabs that other node.
Yeah.
Yeah, it's just a 2-vertex graph.
Okay, All right, so let's take a look now at what that means for. So you're saying the analog of subgraph is what you are currently calling molecule part. Is that a true statement?
Yes.
What is this in the literature of computational chemistry? Is there a name for this thing?
Substructure. Right, Jason?
Right. So the pattern I would call a substructure. And then, I mean, the resulting thing. So this is something that we haven't really fully mentioned. But so when we take the molecule part, we find we extract those vertices in the second argument. And then we will also fill in any empty hairs before returning it to you, because we want to return to you a full and valid, chemically valid molecule. So,
although one might not always want that, you could return a pattern as well.
Right. That's a very good point. It's not implemented yet, but yeah.
Okay. All right. So what you're saying. So you're saying, what would happen if instead of calling it molecule part, one called it molecule substructure?
So the name molecule substructure makes me think that it's not just a function that acts on a molecule and returns a molecule. It would be, let's see. I mean, so to me, molecule substructure could also define the patterns.
Right.
Of a noun rather than a verb.
Yeah, well, okay, so the problem with molecule part, I mean, it's too mathematical to say anything like that, but that is what it is. But let's see, molecule position. Is it better to have the part position cases analog, even though it doesn't do exactly the same thing? What do we think here?
Well, yes. All of those things are common operations that are done on a molecule by a computational chemist.
Yeah, but so what should they be called? I mean, so we've got molecule part, molecule position, molecule cases.
So do we all agree that molecule extract would be the wrong name instead of molecule part? I like molecule extract, but I've never been one to use extract. So I don't. I
think it's kind of crazy because you read it as molecule extract, and somebody's going to think it's some,
like vanilla extract on your spice shelf.
Yeah.
And so then
sometimes it is more extract-like.
What's that?
It extract preserves. When you do extract, you get something back of the same structure. Part you usually don't.
I don't follow, Roger.
When you do extract of a matrix or a tensor or something like that, you typically get back something of the same structure.
Why? I mean, it depends on where it dug down to in the tree.
Of course.
Yeah, but for an arbitrary expression, extract can cover multiple levels and so on. It can return a list of parts.
Okay, I have a proposal. Okay, my proposal is that we call them things like molecular. Maybe this is crazy. This is probably crazy. Because what bothers me, molecular position. Is that absolutely crazy? Because what's troubling to me is molecule part just seems, well, comments about these. Molecule position just seems very weird, whereas molecular position seems like it is, a more reasonable way to say what we have?
So to me, molecular instead of molecule, it makes it, I don't know, it makes it wordier, I guess, even though, I mean, it makes it longer. I don't know that it, right. And I don't know
that.
Right. But I don't know that it's, that it conveys more information. I don't know.
It's like a sub-molecule.
What's that?
It's like a sub-molecule.
Yes. But I don't know whether a sub-molecule is just a term that nobody uses.
I think sub-molecule could fit here. And I, instead of position, or instead of molecule position, I was originally wanting to, or one of the names I was toying around with was substructure position. But the point was made that it wasn't.
The word substructure, without referring to molecule, is not going to work.
Right, that it's too general and it would apply to many other things.
It's not going to work. So take it off the table. It's not going to work. The
submolecule position. So that.
What? Oh, yeah. Yes. I mean, right. Submolecule position. Submolecule cases doesn't really work.
Well, you could have a bunch of these functional groups and you want all the functional groups in there and then you could have...
No. I understand what it would do. The word doesn't work.
Oh, okay. Sorry.
I have to say, I think these are the least ridiculous of the things I've seen so far. The problem that I have with molecule part, I don't know. I mean, molecule position.
Well, molecule part to me sounds like it's very specific to the first argument, whereas molecular part sounds a little too general. Although, it would be referring to some part of its first argument.
Yeah.
And I guess the name would grow on me as I used it more. It just sounds a little unfamiliar, that's all.
This will be my first take on what we should do with these. Let's keep going for right now. Atom and bond patterns.
So atom list, atom count, bond list, bond count were made kind of while looking at vertex list, vertex count, edge list, edge count.
Fine. So if I just do a pure atom list here, I will get out. Okay, what's the order of those things? Oh, I see. That's the number. That's the position that they are in those are the labels of those particular atoms in the molecule.
So that's essentially it just gives you the first argument of the molecule, right?
Okay, so atom count. If I make this atom count, really? Why am I not getting the count of each? That's kind of why is that even useful?
Wait, what were you expecting?
Atom count. I was expecting an association with the number of carbons, the number of this, the number of that.
That's not what that's not what vertex count gives you.
I mean, knowing the number of atoms in your molecule is very useful.
Oh, it is? Okay.
Right. I mean, just anytime I'm looping over the atoms or doing something, I find that function to be pretty useful myself.
Okay.
Yeah. Now, what you just proposed, Stephen, getting an association back in the number of carbons, number of hydrogens, etc., itself would also be very useful.
Well, so let's call it atom counts. That would be the analog of counts for a list. Make sense?
Yeah, I wasn't familiar with counts, but I will look at it. Yeah.
Yeah.
Okay. I think it's less useful for bonds. I think atom counts make sense. I think bond, it's just you want the list of bonds, and there's no bond count either. Is there?
No, there is. Sorry.
Why is that useful?
Yes, the bond count is useful, and I think bond counts would also be useful.
And what would it give you? Because each bond there is a unique thing. So what would bond counts do? Because there's only going to be one bond between 7 and 8, for example.
That's true. Okay, I was expecting it to return the number of single bonds, number of double bonds, number of triple bonds, number of aromatic bonds, number of dative bonds.
Okay, fine. But then that would return. Then I suppose what we would have to do there is to return something like, it's a little weird, something like this. I mean, the other way to do it, I suppose, would be to do something like that. That would be sort of conceptually correct, if a little messy.
Yeah, agreed. For atom counts, then.
Atom counts is not a problem. Well, the only question for atom counts is whether the left-hand side is atom C or just C, arrow, whatever.
Yeah.
Right, and that would apply to atom list as well. I mean, I canonicalize your molecule to always have a list of atom objects, but if you ask for the atom
as our discussion of isotopes indicated, don't we have the possibility of having to decorate those atom things?
Right, and so we could make the decision that when you ask for the atom list, return the string only if it's simple, and if it's not, then you return the atom object. Right now, it always returns the atom object.
Well, we could give another argument to atom list that can determine whether that's what it does. I mean, most of the time, you're just going to have string names for elements, right?
Right. I mean, when a user enters a molecule, that's what they would do. I would expect them to type C, O, F, but I canonicalize it to always have atom C.
I think it should be atom of C by default from atom list. Mm-hmm. Let's talk about this in-ring false.
Right. So that's one of so that's essentially how you enter an atom pattern. An atom would take the first argument telling you what type of atom it is, and then everything after that is rules.
What kind of things are in there?
Let's see. So when you're making a chemically valid molecule, the list of rules would include formal charge, mass number, or unpaired electron count, and possibly.
Okay, but this is another one. This in-ring, which is a very strange part of speech and so on.
So then these are various. So then when you make a pattern molecule, it can have.
I don't like in-ring because it's a different form. I mean, it would be something like ring element or something, or ring atom or something.
Cyclic or acyclic would be more conventional.
Okay.
So it's a Boolean property. So it's a property that you can ask.
I understand. I mean, it's a. What do you mean you can ask? You can ask whether. How can you ask?
So you could do a molecule value of a molecule. Comma in ring, and you'll get a list. You'll get a list of true false, the length of the list of atoms, or you could ask it for a particular atom. You can ask.
That seems wrong. That's what molecule value gives you. I would say that would be something like atom map, if that's what that's doing. If it's giving you something for every element, for every atom in the thing, mapping over all of them, right?
So molecule value is there to give you property values of the molecule, and for properties of atoms that depend on the molecule, I was using a molecule value for that as well. So say you want the formal.
Yeah, but fine. But so that's saying that in the case where it is an atom property rather than a molecule property, then you're doing you're automatically mapping over the atoms in the molecule. Is that right?
Right. So the way I have it constructed there, a property can have a qualifier, just like an entity property. And so the property qualifier in this case is atoms, the string atoms. So you could ask for there would be a molecule property, formal charge, comma, atoms go to 1, 2, 3.
That's really weird.
That mapping over, does it ever need to look at its surrounding?
Right. So most of these properties, it depends on the rest of the molecule. There's only a small subset of the atom properties that are independent of the molecule.
Which indicates
Right, but I mean, Roger,
map-like.
what's that?
It means it's not map-like.
Yeah,
You're not extracting the atoms.
Yeah, that's correct. So in this case, this in ring, I really do not like that.
Okay.
I mean, the right way to say it is when you say it is cyclic, what's the it there?
It means it's part of a cycle. It means it's part of a ring.
I understand, but I'm saying when you say cyclic, I don't think that the term, you don't say, oh, that's a cyclic atom. You say this part of the molecule is cyclic, right?
Right. The atom is in a cyclic environment, strictly speaking. The atom itself is not cyclic, but its environment is cyclic as opposed to acyclic.
Yeah, I understand. Is it always a ring that it's in? How can it be anything other than a ring?
Chemists, we talk about rings, and then graph theory calls them cycles.
No, I understand.
Yeah, but in propane, for example, the 3 carbons are all acyclic.
Sure. Well, I mean, so one could call it ring element or something. That sounds a bit wrong because it's, I mean...
It's a bit algebra, like a ring element.
Oh, yes.
Okay. Well, so I don't like that name. I mean, again, what are the other names you were telling me?
Right. So you can ask for the total bonds or
No. Not inside an atom. I'm talking about the other properties of an atom. You said formal charge is one of the properties, right?
Right. So then mass number.
Yeah, okay, fine. So there's things like formal charge, mass number. Okay, so with those parts of speech, what would be the analog that will tell you whether it's in a cyclic environment or not?
Right, I understand. It's
I think that's very obscure to say cyclic environment. Or is it not? You tell me.
For a computational chemist, it's a bit long-winded. They would just say cyclic or acyclic.
Yeah, but it isn't. Look, it's not the atom that is. You say this carbon is acyclic. Do you say that? I don't think you do. I think you say about the whole molecule.
Actually, I think they do. They would refer to an acyclic carbon as opposed to a cyclic carbon within a molecule.
Okay, we got to have another name. In ring doesn't cut it. Okay, so
I think we agree with you there, but we're struggling with a better name.
right. I mean,
are there other things that sort of allows you to so this one reach it out and look at the connectivity structure around? Are there other ways that you give that, like little constraints like that?
So for a pattern like this, I mean, you can specify the partial charge, which is something that needs the rest of the structure in order to compute it.
No, but Roger is asking something which doesn't, on the face of it, which is like, he's asking for other graph theoretic properties, of which there could be many. I mean, this could be one level in a dendrimer or something, and it knows that it's in this dendrimer and far away from.
Maybe you call that backbone chain something, and maybe you want to say, I only want the carbons in the backbone chain. Let's say
that's a good example. It would apply to a few fields of chemistry, such as proteins, nucleic acids, polymers.
Okay,
and,
so
But what about things, cyclic compound, true or false? Right. So that means that element is part of a cyclic compound or not.
But unfortunately, the word compound has trouble in chemistry.
Yeah. The whole molecule can be called cyclic or acyclic if it has any ring in it at all. Specific atoms within the molecule, in my experience, have been referred to as either cyclic or acyclic also, whether or not they are in a ring.
So,
Determined by whether or not they're in a ring.
Yes.
Sander from our live stream suggests relative position arrow cyclic or not. But I don't think that's quite right.
So let's see. So we have various count properties. And so there could be ring count. So the number of rings that this atom is in.
That's nice. And it would just be 0 if it isn't in a ring.
Right.
True. The actual count of rings, though, Jason, is that strictly unambiguous?
No.
In terms of number of rings?
We have a particular algorithm for finding the smallest subset of smallest rings.
Exactly.
And we follow that.
And it would have to be that, and it would just be the count of the membership in those rings and that set of rings.
That seems a little obscure. Well, I don't know. You tell me whether that's
It's not obscure. It's just part of computational chemistry. This was recognized 30 years ago. The smallest set of smallest rings.
Right. So possibility here is ring count, which is 0 if the thing is on a non-ring.
Mm-hmm.
Sounds like a cycle basis.
What?
Right. The smallest set of smallest rings, the cycle basis.
Yeah.
I see that in the code.
Yeah. Is there a cycle basis for graphs?
Yeah.
What do you call it?
Can't remember now. Charles?
Let's see. Cyclic basis, I think. Don't remember.
That is hopeless.
Well, don't remember.
Information here. We should figure that out.
So we have find fundamental cycles.
Right. That's actually that. No. What fundamental cycle give you the basis? Well, I look for that.
So then if we have the property as ring count, it could be 0, it could be greater than 0, or it could be a number.
Sigh. Are you suggesting it would actually be greater than 0 like that?
Right. I mean, you can do that with formal charge or any of the other atom properties that I have set up.
I mean, there's not just one ring, right? There are multiple versions.
Right. So this is all. I mean, I started out just using the smarts language, this regex for molecule patterns, and there one of the things that you can set in a smart string is the number of rings that something is in.
But if you have oxygen in there, you have a different ring then, right? I mean, can you distinguish if it's a benzene ring, an aromatic ring, or something else?
Well, so then you have to make a pattern to cover the whole ring at that point.
But in this case, your S ring is really not the right thing here.
Okay, so I'm sorry. So you're saying the ring word isn't the right thing, or what?
No, there are different kind of rings. Jason only shows the carbon rings, but there are sync rings with nitrogen, oxygen. Where you replace one carbon by oxygen or nitrogen or the others.
Right. So at that point, you make a more complicated pattern than just an atom. Right. So this, we're talking about a pattern for an atom, and
in this case, you would say you would give the pattern for the aromatic ring. What would that be?
So a pattern for.
What about just calling this ring member arrow true or false?
No, that's good.
That's good for that. If you wanted the bridgehead carbon, though, in other words, an atom that was in 2 rings at the same time, and there are 2 atoms like that in the example immediately above.
Robert Mosher on our live stream suggested ring member right around I just saw the message. So good. Multiple minds think alike. Okay. But you're saying if you actually wanted, see, to me, it seems like it's going to be obscure. This ring count thing is going to be kind of obscure.
Right, agreed.
So, I mean, conceivably, you could have a hack of having the right-hand side of ring member be a number. Let's move on. I think we've got a reasonable resolution for this so far.
Let's see. And so one more point, when you do atom list, as a convenience, you can give a rule as the second argument. Pattern goes to property. And if it's an atom property, then we will return the list of values.
So what kind of forms do we support here? Do we support smarts, smiles, pattern, or?
So let's see. So for an atom, you can give a smarts pattern as an atom.
But I could give also smiles, right?
No.
Okay.
So this is analogous to regular expression of blah, 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 right? This thing here.
Yeah.
And I probably suggested this in a previous meeting, that we actually have this I mean, what's the possibility? I see. I mean, if we were to say, so this thing here turns into a molecule, one of our pattern molecules. Is that true, or does it just sit there as an unevaluated sort of smart string?
It just sits there. Let's see. I wouldn't mind in the future being able to do to convert it, but at the moment I have not written that up.
Okay. So if you were to convert it, this could be molecular pattern and be perfectly happy. And you could give us a second argument what kind of, that it's a smarts molecular pattern, but it could default to that.
Yeah, possibly.
So you're saying not have smarts pattern as a head? That's
what I'm saying, yeah. But just have molecular pattern of, C equals O or something. And then that would be the same as saying that, comma, possibly when we even want something like this, smarts arrow that.
Mm-hmm.
So not as a second argument?
Well, so
I'm not sure.
So in this case, I mean, the way that a molecule, if you give it just a string, it will try and see if it's a smile string right away. And so in this case, molecular pattern could do that as well. It could just say you've given me a string and I assume it's a smarts.
Yeah, exactly. That's what I'm suggesting. Yes, exactly so. That would be the default. But were we to use some other future kind of string, it might be a second argument or it might be in this form here.
So
go ahead.
So earlier on, though, I thought that we were talking about moving away from having a molecular pattern head.
Yes, but the point is that you need some way of taking your string, because that string means something different, doesn't it, in the molecule case than the molecular pattern case?
Absolutely.
Explain the difference.
So let's see. So as a smile string, that carbon specifically has two hydrogens, but as a pattern, it has two hairs, so to speak. Or and two hairs, and those two hairs could be bonded to one carbon, so you could have two double bonds on either side, or it could. So you could make a molecule that is C equals O, to use that, and it would match on that smarts pattern.
Okay. So, I mean, to me, graph pattern is going to end up being something a bit similar to this. It's going to be we don't have it yet, but it's going to be some kind of hairy object, is it not? Hairy in the sense that it has dangling hairs that are edges without a vertex at the other end of them. Is that right? Charles, Roger?
Yeah, I mean, there will be a vertex, but you don't care what it is.
Writing the specification, I guess, yeah.
Right.
Is that what you mean, Stephen?
That's what I mean. Yes, it is like
Like in any vertex,
Yes,
like we use
correct.
underscore for.
Right. Right. But I mean, your molecular pattern, if I'm not mistaken, could equally well. So I'm a little confused by this. Is it the case that molecular pattern has some bonds without anything with blank essentially at the other end, or does it have something different in it?
It simply omits them.
Because in this case here of the C double bond O, the hairs could be two single bonds or it could be one double bond, and they're different, but the pattern C double bond O would match to either of those cases, either of those situations.
I'm a little confused. Is it just the analogy? Does the analogy hold that a graph pattern would be a graph with, could be a graph with certain vertices being given as blank? Am I making sense? So it will be something like this.
Yeah, but in a way, if you do the analog of graph here, there's sort of other properties, okay? So we have different kinds of edges, okay? And that would be modeled as a property, like you can have in all kinds of other contexts. Is this
okay, so something like this, right? Well, that's doing a goofy thing because that's treating blank as a literal vertex, right?
Right.
Yes.
Okay, so what I'm saying here is maybe there should be a graph pattern in which the blank here means essentially a hair.
We use it as a graph pattern already throughout. Wherever you select something, you specify properties, we use graph patterns.
I understand, but you use graph patterns as you don't use actual graphs as the graph pattern, do you? You just use the naked.
Because we can talk about the objects themselves, but what I could imagine that you want, if you have sort of more advanced functionalities, to make it substantially simpler to also include properties in when you want to match things. Because
I understand. Right.
Although the simple structural notion of a graph is there, but other properties really matters. Like in chemistry, we really care that it's a carbon versus an oxygen.
Right. Well, so my provisional conclusion would be that molecular pattern is essentially a simple syntactic wrapper which happens to take in smarts, but it also is a way of specifying that things have hairs on the end, so to speak. Does that make sense to people?
I think it does to me.
Okay. All right. Okay, let's keep going. Maximum common substructure.
And so this is a case where it would be desirable to actually return a molecule pattern object with a list of atoms and bonds, but at the moment the library I have returns a smarts pattern.
Well, that's a mess. So, but can't you turn that into? Yeah, okay. So you'd have to decode that as a molecular pattern.
Right, and that is definitely in the plans.
Okay.
Can we do that with strings? Can we go from a regex to a string expression in all cases?
No, we don't have that capability at this time.
Yeah.
And nor do we guarantee that it's possible.
Right, and that may still be the case with smarts versus a Wolfram Language molecule.
Oh, so then worst case is that what you return here is molecular pattern of that string.
Oh, the smart string. Okay.
Yeah, and the string doesn't resolve.
Right,
Okay.
but in this case, it would actually be fairly easy to.
Well, fine. If it can resolve, it does resolve. But if it can't resolve, it just stays there as a smart string.
Yeah.
Okay, this maximum common substructure. It's a weird,
it's a name that has some traction in the community, but I know that it has no, it doesn't say anything about chemistry in the name.
By the way, should it be max common substructure? I don't know how that's consistent with other things or not.
I think max is consistent with other usages within the language, like max iterations.
Yeah, that's what I think too. Okay, so this is where you're doing the selector as well as the... Oh boy, this is pretty funky. Because in the case of entity value, for example, that third argument is not a selector argument.
Right. So in an entity value call, the property and the qualifier, they get subsumed, and there would be an entity property, mass number, comma, atoms goes to 7. And you don't have, if there's only one.
What on earth is this? This is crazy. That is analogous to nothing.
Okay, so I'll take that out.
I mean, it really doesn't make any sense.
So I came up with a function called a register molecule property that would allow a user to register a property with their own name if they wanted to use the...
Why? Why can't they just use assignment? I mean, I don't understand. Why can't they just make a function that does what they want?
Yeah, that makes the most sense.
Then yeah, I'll take that part out.
Okay, what's this thing here? This seems
Wasn't
crazy.
that assignment the thing that you were upset about? That is an assignment.
No. This here, Roger, this here. I don't understand why this isn't molecule value of molecular part of M, 7, mass number. Do you get what I'm saying?
Right.
Well, so molecular part, as discussed above, would evaluate. So there would have to be a different...
So what if it evaluates? What's wrong with that?
So lots of the properties of the atom would change if you took it out of the molecule.
What a mess. Because we can't have something which is both... Yeah, I understand, but we can't have two different ways to refer to that atom. Because one way of referring to that atom is to say molecular part of M, 7, right? And that appears to extract that molecule, that atom, basically. Whereas this is the in situ version of that, asking about... I mean, if you're going to do that, I would have thought you have to say molecular property, and then you've got to be able to say M, and then you've got to be able to give the part specification, 7, mass number, where maybe that second argument is optional. Do you get what I'm saying?
Yes, defaulting to the whole molecule.
Yes.
And if we wanted to do something based on 3 atoms in the molecule, it would be a list of those 3 atoms for the second argument?
Yes, it would, but I don't know whether it's listable by default there, or whether it's...
yes, that's another good point.
Or whether it's an aggregated thing. I mean, you might want either of those.
Exactly. I can see uses for both.
So the function that you have here, molecular property, that would return the property value?
That is correct.
Yeah.
So that's different than
molecular value. Okay. All right. I'm changing my mind about what that should be called. Okay. So let's say it's called molecular value. And then there's the question of listability of that second argument.
And then also, does the part specification go in the second argument? Because oftentimes you're going to be calling molecular value M and then just a property name.
I know. We just said it's an optional second argument. Okay, so that would also work. And that would be equivalent to, presumably, this. See what I'm saying? But we need other examples of what the second argument, I mean, what the property argument to molecular value can be.
Right.
So the other thing we could do here is have a decorator of some kind for this. But you're saying that molecular part, which is the most obvious thing to use here, can't work.
Yeah, because that takes it, ex situ, would that be appropriate? It takes it out of the molecule, and we don't want to do that.
Right.
And I would also argue at this point that molecular value is not listable. If you want it listable, you'll just have to map it over.
I agree.
Wait, hold on.
It's not listable over these elements because you might want the aggregated, some property here that is aggregated, some weird chiral property. You've got 3 atoms. You want to know whether they make a, I don't know what all your weird
a chiral center or not. Yeah.
But shouldn't those properties be exclusive? I mean, what property would apply to one atom and then to 3 atoms?
For example, you want the mass of those 3 atoms out of the molecule, the total mass, or the net partial charge, something like that.
See, to me, that seems that you would just apply total at the end.
You could,
guys. I am super late for something else, so let's stop here. I think this is going in a reasonable direction. I don't think we've necessarily solved this, but what we've got to see is what the possible names here can be. Okay, make sense?
Okay.
Who's PMing here? Was that Andrea? I heard.
Yes, I'm here. But I'm just PMing on the meetings. I'm not the PM of the project, but I was assigned for this Twitch meeting.
Okay. Okay, who am I sending? I'll send this back to Jason then. I've got
and me.
Okay.
Please.
Yep. Okay, I'm not saving this notebook. This is just being saved, so I'm just sending this back to you guys.
Okay.
Okay. All right.
Great.
For those
Thank
who
you.
are on the live stream, we are actually going to another live streamed meeting, so you are welcome to join that. Thanks everybody, and on we go. See you all soon.
Bye.
Bye.
Bye.